In this session, we are going to discuss the super node analysis. In our previous session, we have discussed the nodal analysis. In nodal analysis, we apply the Kirchhoff's current law and then determine the node voltage. Once you have node voltage, we can determine the branch current, the mesh current. We can also determine the branch voltage. Now, in case of the super node analysis, this is also the application of the Kirchhoff's current law. Now, in super node, we also have to apply the Kirchhoff's voltage law. Similar to the super mesh analysis, we have to apply both the Kirchhoff's law. In case of the super mesh, we apply the Kirchhoff's voltage law first, and then later on, to get the required number of unknown equation, we also apply the Kirchhoff's current law. Now, in supernode is formed when there is voltage source in between the two nodes. There are two cases. The first case is when the voltage source is in between datum node and non-reference node. Now, this datum node, we also call it as a reference node. Now, remember that the first case is when the voltage source is in between the non-reference node and the datum node. Now, in case of the super mesh analysis, we also have a two case, right? First case is when the current source is in between the current source is only at one of the mesh. Now that one was the case one. Now, similar to this one, in the super node, the voltage source is in between the datum node and non-reference node. Now for this one, our solution is very simple. We simply set the voltage at non-reference node is equal to the voltage source. For example, here in this figure, in this network, we are giving this node voltage V1 is equal to 10 volt, because this 10 volt, this voltage source is in between non-reference node and then the datum node, or we simply call it as a ground. It's in between the reference node, non-reference node and the reference node. So we simply give this V1 is equal to 10 volt. Now, second case is if the voltage source, be it dependent or independent, is in between two non-reference node, we form generalized or supernode. Now here, the supernode, when you say about supernode, it's bigger node. We are forming the big node. A big node, when I say about the big node, there are many number of branches coming together. See, in V2, here we have 3 branch. In this node, it's also coming 3 branch, but when you form, it's almost coming like, it's coming 4 number of branch. So in this case, this voltage source is in between node V2 and node V3. Now, how to solve when you have this kind of case? First case is very simple. We're simply giving V1 is equal to 10 volt. Now, for the second case, is in between the two non-reference node. Now here we have to form the super node. V2 and V3 we have to club together and form the super node. And once we form the super node, we have to apply the Kirchhoff's current law at the super node, and then we will get one of the equation. And again, after the Kirchhoff's current law, we have to apply the Kirchhoff's voltage law. Now, if you have understand the super mesh analysis clearly, then it's also like a similar step that we're applying. In case of the super mesh analysis, we apply the Kirchhoff's voltage law, and then in the second step, we are also applying the Kirchhoff's current law. In this nodal analysis also, in the super node analysis also, we are applying the Kirchhoff's current law and the Kirchhoff's voltage law. Okay, in this case, case 2, first one is we are applying the KCL at this node. Here current I1 is coming in, current I2 is going out, current I3 is also going out, current I4 is coming in or entering to this super node. And then from here, from this super node, you will get one of the equation. And then second step is we have to apply the Kirchhoff's voltage law. Now Kirchhoff's voltage law says that the sum of the voltage in this loop or this mesh is equal to 0. Here you have plus 5 volt, then you have V3 and then V2. Now remember that you have node voltage here V2 and V3 here. Now this node voltage with reference to this the reference node, then this branch voltage will be equal to the node voltage. So we are taking this branch voltage as a V2 and then this branch voltage also V3. If we apply the Kirchhoff's voltage law at this, then we will have minus V2 plus 5 volt plus V3 is equal to 0. Why we are taking here negative? Our assumed current is entering from negative to plus. So we are taking minus V2. Then here is entering from plus to minus. So plus 5 volt. From here plus to minus, we are taking plus V3 is equal to 0. So how many number of nodes here? Originally we have 1, 2 and 3 nodes, right? We have 3 nodes. So the number of equation that we should have is 3 minus 1. Now how many number of equation that we got? One equation from the super node and then one equation from the Kirchhoff's voltage law. So we got 2 equations. Once you got 2 equations, you can solve that equation simultaneously. The first one is we're applying the Kirchhoff's current law at the super node, and then second step is we're applying the KVL at this. So now for this one, your I1 is equal to V1 minus V2. Then I4, this is I4 is equal to V1 minus V3. Here I have written here. And then I2 is equal to V2 minus 0 is given here. And then I3 is equal to V3 minus 0 divided by 6. So to determine the current for this one using the node voltage, you have to apply the Ohm's law, right? So we have V1 minus V2 divided by the resistor at that branch is 2 ohm. V1 minus V3 divided by 4 ohm is equal to V2 minus 0 divided by 8 is 8 here, and then V3 minus 0 divided by 6. So we have solved like this. We have framed the equation, and then about the solution here. Now if we rearrange the given equation, then we get V2 minus V3 equal to 5. Now let's give name of the equation 1, and then for the second equation is 15 V2 plus 10 V3 is equal to 180. Now let's keep this one as equation 2. Solving equation 1 and 2, we get V2 is equal to 9.2 volt, and then V3 V3 is equal to 4.2 volt, and then we already know V1 is equal to 10 volt. Now this is how we should solve the super node analysis. This is how we should apply the super node.